All right, I think we're live now. Hello, everybody.
Okay.
Hey, Daniel, can you hear me? Just confirming my microphone's working.
Yeah, good for me.
Yeah, all
Wonderful.
good.
Thank you. Thanks, Ed. So again, welcome everybody. Welcome to our next segment of Office Hours at Think. I think my name is Upkar, and I'll be your host for the next hour or so. So first, I'm hosting the team that presented a session on Cloud Foundry migration runtime. Before we get into the audience questions and chat about what you presented on, I would love for the team to introduce yourselves. So Ed, can we get started with you?
Sure, yeah. Thanks, Upkar. Hey, everyone. I'm Ed. Ed Shee. I currently lead the UK developer advocacy team here at IBM. So our team is like, developer advocate is kind of like a weird word, right? People go like, what on earth is that? But our team is basically the public face of like IBM's technical products and open source and so on. So everything in the developer community that you need help with, we're here to do that. We write the code samples, the blogs, the tutorials, etc. And generally, spread the word around the great technology that IBM builds.
Wonderful. And Daniel?
I'm Dan. I work for HCL Cloud Native Labs. I've been leading the development of the IBM Cloud Foundry migration runtime, which was the subject of the previous session.
Thank you for that. So I guess my first question before the audience jumps in here is for folks who are watching this Q&A but didn't get a chance to attend the session. Can you give a quick introduction to Cloud Foundry migration runtime to set the stage for us?
Sure. Do you want? Is that to me or Dan?
Anybody.
I tell you what we'll do.
Okay.
Except me.
I'll do a quick overview of what I covered, and Dan, you can talk more about Cloud Foundry migration runtime.
Okay.
So, because in the talk we did we covered a bit of everything as fast as we could, right, in a short talk format. So I went through a little bit of just kind of like the cloud native computing landscape, and how Cloud Foundry came about, what the problem is it's trying to solve. Which if you're not aware of Cloud Foundry and you've not used it before, it's basically trying to make life as easy as possible for developers to deploy on cloud. To abstract away all the infrastructure and the containerization and things like that for you. And as a developer, I find it's awesome, right? It's a brilliant tool. So yeah, I kind of covered a bit of that and then went into what kind of Kubernetes and OpenShift is, right, in terms of the enterprise containerization platform that it offers, and then hand it over to Dan and Jeff. And Dan, I guess you pick up from there and cover very quickly what you spoke about.
Sure. So in the HCL Cloud Native Labs, we had been working with both customers who were moving to OpenShift and also customers who had more of a background with Cloud Foundry, so Pivotal Cloud Foundry in particular. And we were asked by IBM if we get a Cloud Foundry running on top of OpenShift, the idea being that customers with existing Cloud Foundry workloads who are looking to standardize on OpenShift had somewhere to run them. So that's what we worked on last year, and that product went to GA in December last year. So it's a full Cloud Foundry running on top of OpenShift. So the actual user applications run as Kubernetes native stateful sets, and from a developer's point of view, when they're using they can use all their existing tools because they're going to the same Cloud Foundry API.
Thank you for that. And I see Jeff also joined us. So hello, Jeff. Welcome. So Jeff, we did a quick round of introductions. If you don't mind introducing yourself.
Yeah, so my name is Jeff Bonagin, and I work with Dan, based out of the HCL Cloud Native Labs here in London.
Thank you. So going back to Ed, what you said about Cloud Foundry, I found it interesting. You had a slide on the open source nature of Cloud Foundry back in the day, and you mentioned Heroku a couple of times. What were some of the benefits of it being open source, and why was it necessary at that time?
Yeah, that's good point, right? And as I mentioned in the talk, right, like Heroku, I think have created a great product, right? And it's and are responsible for a lot of the like great developer experience that people have around PaaS, and I think that's really cool. But it doesn't necessarily give you the flexibility as a, like, let's say you're a government agency, right, who need to run your applications within your own data centers behind, like isolated from the internet, or you have your own firewall rules or like regulations or compliance reasons that you have to have stuff on-prem, right? That makes it really hard to be just saying, do you know what, I just want to throw it at a cloud provider and have them run it for me. And so for them, they have the options of like taking a vended on-prem offering, and that's what Pivotal then did with Cloud Foundry, right? Was they took the open source Cloud Foundry, contributed a hell of a lot to the project, but then built a business around running a managed and supported version of that for corporate customers. But because it's open source, it means if people want to build their own and tweak it and add extensions and so on, they can do that. So there's no reason why I can't run it in this room right here on a server if I have one hiding in the cupboard behind me. I actually don't, though, unfortunately. It would get pretty warm in here otherwise.
I think Dan has started to build his own data center in his closet.
Yeah, and then I guess the other thing is like is avoiding that lock-in that you sometimes get with vendors, and for something like PaaS, it's easier actually to switch. So people who are familiar with Heroku pick up Cloud Foundry really easily, and vice versa. The further you go down the infrastructure stack, the harder that becomes, though. Like, if you've built everything out on a VMware estate, right, it's really hard to then go and deploy that on a totally different cloud. And so the beauty with Cloud Foundry is that, as a user, I could go to IBM, I could go to Pivotal, I could go to SAP, or, all of those run like managed Cloud Foundries. And actually I can build a really clever like CI/CD pipeline that deploys it to all three. So I have failover built in that if IBM's data centers fall over or get attacked or whatever it is, my apps keep running.
Yeah. No. So I've as a developer advocate for IBM, I've dealt a lot with Cloud Foundry. I use it at hackathons when I'm mentoring, and for Call for Code teams. And I love the ease of CF push and just have a manifest file and kind of all magically, I shouldn't use that word, but it works without a lot of tweaks. But it's flexible enough that I can override a lot of that. So let's take it a little bit forward. So for junior developers who haven't dealt with a lot of Kubernetes, or they're coming more from the Heroku world, with CFMR, and this could be for Dan or for Jeff. How much Kubernetes do they have to know if they want to use something like this to migrate their existing applications? And I'm saying as a developer.
Yeah, so I think that's the nice thing about it, because Cloud Foundry is a consistent abstraction. And as far as the developer's concerned, when they're using CFMR, they're just using another Cloud Foundry. There's nothing to indicate that it happens to be running on top of Kubernetes, or in this case, OpenShift. So they don't need to know anything about the underlying OpenShift platform unless they want to. And that's the idea and that's the idea behind it. If you know Cloud Foundry and you're comfortable with Cloud Foundry and you're used to doing your CF push, you can start using CFMR. But as you start to learn more about Kubernetes and more about OpenShift, you've got all that under the covers as well. So you can start developing natively for OpenShift. So you can go at your own pace, and as you learn more about Kubernetes and OpenShift, you can start using the underlying platform. But while you're learning, you can keep on using Cloud Foundry like you've done before.
Yeah, to add to what Dan is saying, as we had shown on the demo, like the entire CF experience is completely the same. Like you're still doing the same CF push, CF apps, CF login. So if you've apart from your developer experience, if your development processes is sort of built around this whole CF CLI, then it's easy for you to also just migrate that over to using to point to a CFMR environment and sort of continue with your processes or your pipelines. So yeah, that's really the benefit from a developer's perspective in being able to use CFMR.
Okay. So if since it installs on OpenShift, then as you're developing, Dan, if I understand you correctly, as you're developing your Cloud Foundry applications, that's the world you know. If you wanted to, you could also transition or look in how OpenShift works. It's almost like a path towards OpenShift if you wanted it to be that way. Did I catch that?
Yeah, that's the intention, and that's why Cloud Foundry Migration Runtime has migration in the name. It's intended as a tool to help you make a smooth transition.
Okay. Now, the one thing I'm not sure if you talked about it in the talk. Would it be possible to install that? Well, first of all, what does the installation process look like? And I know folks can go read the documentation, but if you can spend a minute on it. And also, would it be possible to install CFMR on something like Minishift or cloud-ready containers to try it on my own? Or would that even make sense?
You want to take that, Jeff?
Yep. Yeah. So we had actually as part of the productionization process of CFMR, take into account the kind of different customers that would want to install this, the different environments that want to install this. We want to go with something that's as simple as possible, and the way to do that was by using Helm-based operators. So initially, we were just doing Helm installations. Now we're doing different Helm installations of the different components, and we need something that's a bit easier than doing 4 or 5 Helm installations. So we figured, okay, let's capture all of these configurations somehow, and figure out a way to better install this in an easier way. And which is why we went with Helm-based operators. So that way, you basically have just one custom resource that defines your entire CFMR environment, and you only need to deploy one CRD and one operator to sort of enact on that custom resource. That way, your installation, your uninstalls, your upgrades is basically done by just doing operator-based installations.
Yeah, I was going to add to that. I think it's actually a really good example of why Kubernetes operators have seen so much growth and why they're such a useful feature. As Jeff said there, right? Having to install 5 different Helm charts, or in some situations, right, you see operators that are replicating 15, 20 Helm installs. Taking that away and also automating it so that that it's all standardized is It's just like, it's such a beautiful feature. And that's why, particularly over the last year, like, we've seen so much growth in that area.
And I think you asked about running on Minikube or cloud-ready containers. I don't think we've actually tried it on that scale. Have we, Jeff? We've tried it on. We've tried it. So sort of minimal recommended installed is an OpenShift cluster with 3 worker nodes. So 4 CPU, 16 gigabyte of RAM per node, which is the happens to be the minimum cluster size of a ROX cluster on IBM Cloud, and that works nicely. And obviously that requirement is a lot lower than a traditional Cloud Foundry installation, which would be on 20 odd VMs. We've also had it running on IBM's new closed satellite product. So we had closed satellite set up in our labs environments, so using our own infrastructure, and then provisioned from IBM Cloud, and CFMR runs on the minimum installation of closed satellite as well, which is quite useful.
In the talk, you also mentioned kubecf. Am I right? And if I recollect, the CFMR is built on top of kubecf. Is that correct? Can you tell our audience a little bit more about how that worked out and sort of the underlying pieces, including kubecf, and how all of that comes in place for folks who are who are more I guess deal with Kubernetes more than Cloud Foundry and might want to know a little bit about what's under the hood. And maybe this is for Jeff. Jeff, I know you present on this a little bit.
Yeah, sure. So I guess we can go through a bit of a history lesson how we got to using kubecf.
Once upon a time.
Yeah, once upon a time, there was an IBM requirement, and it said to go forth and build a new Cloud Foundry environment. So initially we were looking at a project called SCF. Is that right, Dan, if I recall correctly?
Sorry?
And we were looking at another open source project called SCF. And I believe the SCF project had then migrated to what is now effectively kubecf. And the people working on that had moved over, and the development efforts had shifted from SCF to using kubecf. So when we were deciding which project to use, we went with, and also at that time, CF for K8s was just in beta, I believe. And so we had figured that SCF, kubecf, which shares a lot of components with SCF project, had already been in development for a few months at that time. We thought that that was mature enough for us to build on top of. And the good thing about using kubecf and the sort of built-in, or not built-in, but partner project of Quarks is that it was still using sort of a certified distribution of Cloud Foundry. So what the Quarks project and the kubecf project has done is effectively taken the various Cloud Foundry components and turned them into Docker images effectively, which lets you basically orchestrate your entire CF deployment, just like you would any other Kubernetes resource that you want to deploy. So that's quite a powerful thing, being able to declaratively deploy a platform, just like you deploy any kind of deployments on Kubernetes. So we went ahead and started building on top of that. And of course, there were other projects that were attached to kubecf. One of them was Irene. And now one of our requirements was that we didn't want to use Diego as the scheduler for CFMR. we, Diego would have just been another sort of abstraction to what's already a cloud, a pretty abstracted cloud foundry environment. And instead, we decided to use Irene in order to be able to schedule applications rather than Diego. And the really good thing about Irene is that it allows you to sort of deploy CF applications as stateful sets. So they run as pods. You can see them in your Kubernetes environments as pods, which opens up, sort of a whole set of features if you want to, if you're an operator and if you want to manage your applications as well as your platform, right? You can monitor them, you can pull logs from them just like you would in any other pods that's deployed in your Kubernetes environment. Yeah, so all of these things, there were reasons behind why we had picked these open source projects, and they all sort of fit nicely together with each other. And the fact that at that point, the development community, this was another important thing about us picking these open source projects, is that the development community was already established. There were people on the kubectf Slack dev channel who were busy contributing to the project, testing things out, making sure that things are working. If they're not working, raising issues against the projects, and then someone would pick it up. So that was sort of another reason why we went ahead with these open source projects, is because the community involvement was already pretty established. Yeah, so fast forward to where we are now. We've productionized these open source projects to what is now CFMR. But yeah, that's sort of like the journey that we went through and sort of the thinking behind why we had chosen these various projects.
No, thank you for that history. So I'm wondering, since you mentioned the community, where would be a good place for folks to get in touch with the team, or if they have any questions, or want to try out the solution? Is there a Slack channel they can get in touch, or a GitHub repo? I will post if somebody wants to post the link in the chat, that would be great. All right, while you're doing that, I have another question. Do you have, or how has the project, where has the project been used so far? Is it being used in production, or is it mostly in the trial phase? What would you say, sort of how's the community feeling about that?
Yeah, so at least from the actual IBM CFMR side, we've had a couple of POCs done already with various clients, and this is sort of going through an installation process, sort of figuring out what their use cases are for CFMR, if they're willing to run sort of CPU heavy applications or memory intensive applications or cron jobs and things like that. So we've done a couple of POCs with various IBM clients in standing up CFMR. At the moment, we're actually going through an installation POC for a US client. I guess I can't name names, but anyways, and we're sort of figuring out what kind of applications they use, what kind of backing services they use, how they use it, if it's deployed in an air-gapped environment, for example. Yeah, so all these things have sort of been a really good experience for us whenever we're doing POCs for clients. But yeah, the CFMR is definitely out there, with clients actively using them and testing them out.
Great, that's good to hear. Thank you, Jeff. And then I guess Dan and Nate, if you want to chime in, my question is, where do you see the project being headed? What's the future of CFMR?
Dan, do you want to go first?
Yeah, as you said, as we learn more from the customers and our POCs, we're gaining more support for different backing services, and adding additional features. Yeah, and we're also still contributing back to the underlying kubecf project as well, and other depending projects like Irene. Yeah, so it's quite an interesting project to work on, because obviously there's the work we're doing, but then there's the work that the rest of the community are doing on the underlying dependent projects. So there's a lot of work going on and a lot of new features and capabilities being added.
Yeah, and from my perspective, I'd say, despite the name of migration runtime, right, which is very much implying Cloud Foundry users migrate to OpenShift and have this running on top so that you can keep the same experience. I'd say there's also a value add for OpenShift customers there, right? In that OpenShift gives a great developer experience, but sometimes you want something that's just really simple, and Cloud Foundry nails that for developers. So being able to take CFMR and run it on top just gives you that extra option, for people to be able to use an open source PaaS on top of OpenShift. So yeah, there's kind of both ways to tackle it.
Yeah, I would agree. I've had the same experience with Cloud Foundry. It's a good stepping stone or a first step. It's easy to explain, easy to use. So yeah, this is great. Thank you. I want to thank the team for joining me today in this office hour, and also I can't wait to try. Maybe I'll be the first one to try CFMR on a mini cube or a mini shift and see where it goes.
Cool.
All right.
Thanks so much.
Yeah.
Thank you.
Thank you, everybody. Bye-bye.
Bye.
Bye.
Oh, I'm sorry, I didn't mean to take myself off the stream. So that was Team CFMR. I did post in the chat their link to their replay, so you can go watch their talk, and also a link to where you can find more about the project. So now I'll go off screen for a couple of minutes while we get our next team, Team Prometeo, ready to come on stage and do their office hours. So I'll be right back. Thank you. Hello, 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 everybody.
Hey, how's it going?
Hello.
I
Hello.
I love the full screen. I love that we have so many people showing up from the team. Hey, Daniel.
Hello, everybody. How's everybody doing?
Hi.
Doing good, thanks.
Fine.
All right, so I heard Team Prometeo had a wonderful session, and so we are here now in the office hours. We have a few folks watching on YouTube and Twitch, so I'll be bringing the questions to you. Hi, everybody. Welcome. My name is Opkar. I'm a developer advocate for IBM, and yeah, I'll be your host for the next half an hour. And we do have a large team here, but I still want to take a couple of minutes for everybody to introduce yourselves, and then we'll dive into Project Prometeo in detail. So I guess the easiest way might be just me calling out names as I see you on the screen. Marco, do you want to go first since I have you up on the screen?
Hello, my name is Marco Rodriguez. I'm co-founder of the Prometeo platform, and I was part of the Prometeo team when we presented to the contest. And in that team, I was the data scientist. Thank you for the invitation.
Thank you, Marco. All right, Salme?
Hello, my name is Salome. I'm part of Prometeo team too. I'm co-founder too. I'm really happy to be here with you. And Prometeo is a journey, and we invite everyone to join our open source community. We wait for you there.
Thank you, Salome. Laura?
Hi, everyone. I'm Laura Mokreski, and I'm one of the Service Core IBM members. So for my day job, I do hardware verification for IBM Power Systems. And I'm very excited to be here and talking about Prometeo.
Thank you, Laura. John, do you want to go next?
Hey, everybody. I'm John Seagrave. I work in IBM in my day job as a lead data scientist and a technical product manager. And like all these guys, got a chance to work with the really great Prometeo team, and just great to see everybody here and looking forward to the chat.
Wonderful. Thank you, John. Hey, George.
Hi, everybody. My name is George Zacharakis-Utes. I'm part of the IBM Prometeo team, or Call for Code team. And my day job is system design as part of the IBM hardware team. And very excited to be here and be part of this project. It's been phenomenal. Thank you.
Wonderful. Marisol.
Hello, everybody. I am Marisol Santillan. I work as a hardware compliance engineer, and I'm part of IBM Call for Code. I'm very excited to be here today. Thank you.
Thank you very much. And last but not least, our Call for Code Chief Technology Officer, Daniel. Daniel?
Hey, folks. Everybody, great to see everybody again. So I'm very excited as the Call for Code CTO to see the top team, Prometeo, from the 2019 competition back together here with the IBM Service Core team that brought them from the innovation that won the competition through to the latest version that was tested in the field, and to invite folks to take part now in the open source community to take it to the next level. So really excited, Opkar, to hear about the questions you have for the team, and hopefully folks listening can understand about the value of the project, some of the challenges we overcame as a team, being resilient through this pandemic, and of course, setting the stage for how they can contribute to the project or use it in other parts of the world where it might be valuable to additional firefighter communities.
So for our audience, I was also part of Team Prometeo as from IBM, and so I have a little bit of an inside knowledge. I'll be asking you about all the bugs that we have in the repos. No, I'm kidding. I won't be doing that today because we have no bugs and everything works just perfect. So my first question here, maybe for Salme and Marco, for people who are new to team or to the project, maybe and didn't make the initial talk, could you give us a short overview of the project itself?
The project is to resolve an issue. Is that there are no individualized strategies to protect firefighters. So we need data, and we need data from their exposure to smoke and toxic substances. And we started the project from an Excel file. They did it manually. They collect the information from firefighters manually. So we suddenly realized that we can do that. We can collect the data from firefighters automatically, thanks to IoT, cloud, and AI. So that was the beginning of the project.
Mm-hmm.
Okay, and from the point of view of the infrastructure or technology, we created a device, the Prometeo device, we created using Arduino in C, language C, and we developed an application for the mobile in Android, and we use in this case Java, and we developed a dashboard for the command center in the cloud. We developed this part using React with a backend in Python. I think we have a lot of different services resources that we have used, different languages that are quite attractive for every developer in the world to contribute.
Yeah, absolutely. Thank you for that. So you showed us the hardware device, right? So there's hardware, there's I heard IoT,
Yes.
I heard infrastructure, different solutions, and so that's great. So maybe a question more for the hardware folks on the team. Since we have both hardware and software installed, I'm sure the team had to, build and test things. I know, as a matter of fact, Marco had to build a couple of fires in his house, which is a little dangerous. But I'm wondering, given that everything last year was virtual, how did the team come together and work around that? So I'll address that to perhaps to George and Laura and Marisol, especially looking at the hardware side where it's easier to be in the same room and work on that kind of stuff. So I'm wondering, how was that experience like? And yeah.
Yeah, so I can kick us off on that one. I think that, IBM is a global team that is used to working across geographies and across time zones. And so this project was an extension of skills that we've already been using for most of our careers. And not to say there wasn't challenges, but we had the right tools to address them. So, very active using Slack, very active using Box. We use videos to help guide people through assembling these devices and testing these devices. And then a lot of time spent just talking and working through it together online.
Mm-hmm. All right, Laura, Marisol, do you want to chime in? So, go ahead.
Yes, another challenge we faced due to be working virtually was the calibration of sensor, because as Marco shown, he had the final Prometeo device, and we had to calibrate the sensor before the field test. So to do that, and we didn't have enough information from the manufacturer. So to do that, we have to simulate the CO, and Marco did that by burning things at home in a safety environment.
But in a controlled environment. Anyway, we had some help from the university. We asked the university to help us, and we found that they could use calibration gases with us, so it was wonderful. But at the beginning, I used what I had at home, no?
Yes, yes. We need to infer some initial resistance of the sensor. For do that, we need a CO detector that fortunately was lent by the firefighter department to Marco. And with that, we could infer the real initial resistors and verify that the sensor was giving us a good reading of CO. So that was a challenge, but a very good experience.
Yeah, everyone had to kind of do a little more on their own than they would have if we had all been in person. Some people who maybe aren't used to the hardware side had to, solder things and build a circuit in a breadboard and that kind of stuff. Or people who maybe aren't as much on the firmware or software side had to do some of that. So like George said, we did a lot of, videos and box notes on how to do different things, which will be helpful in the future for, actual fire departments trying to, test and assemble the devices. And then we had a few issues with the pandemic and shipping delays and stuff too. So Sometimes it was like someone was developing and then someone else who had hardware had to test what they developed and things like that, but we definitely made it work.
Yeah, I can vouch for that. If their box notes and videos could get me up and running with doing the soldering and the hardware stuff, then anybody could join. Yeah, it was really good.
That's great to hear. So working at IBM, time zones have never been an issue, and this is another project that's come together from people across the world, which is amazing to see. Now, you mentioned, Marisol, Marco, you did, university, a couple of other collaborators. So between Salome, Daniel, could you give us an insight into, they say it takes the whole village. What did the village look like? What does the community look like? Who are the different partners involved in this collaboration?
Well, I think it's a key point because when you start a journey, a project like this one, you soon realize that you cannot do it alone. So we asked for help, and it's true that we received help from this amazing team from IBM Service Corp, but we need more help from partners. So the first thing we explore is the mobile application, and we asked for help to Samsung, and they lent us devices, smartwatches, smartphones. So it was amazing. We received help from them, but also from other partners like Arrow, that is part of the Call for Code family, and from the university. In front of the fire station, we have the engineering university in Barcelona, Universidad Autónoma de Barcelona. So we asked for help to use their labs for the sensor calibration that it was mentioned before. And on top of that, for example, we received the IoT devices from Project OWL in US. They help us with the printing, with the 3D printing. So it was amazing. The family of Prometeo's family was growing during the pandemic situation. So for me, it was the most amazing part of the project. That even in this difficult situation with the pandemic, there are people willing to help us with this journey. So I'm very happy with that, and I would like others and you, if you are watching this video, this webcast, you can join to our open source community. We want our project to become your project.
Wonderful. Yeah, and I think believe it or not, I think the pandemic and working virtually probably has helped this project grow from being something that was localized to Barcelona, where the innovation was created, to expanding to a larger audience of people who know about the project and are able to contribute to it. So I think as CTO of Call for Code, I'm very excited about open source being so central to what we do that anybody can contribute to it, to recreate it, to improve it, to customize it for their solution. For their situation, whether they're now in Australia or Argentina or in the Amazon or in the Western United States or Northern Europe. They're able to take this technology, improve for everybody, but also customize it based on their own local needs. And I don't think that would have happened if we didn't work virtually, if we weren't kind of forced to think about remote first. So hopefully that's one benefit of at least what we've had to be resilient to this year.
Yeah, absolutely. Looking at the silver lining, I like that. So my next question is for John and Marco. So for the data nerds in the audience, and I say that with envy and all due respect, can you tell us a little bit more about the kind of data that you're collecting? Marco showed us the device. There was a little light on the device. Can you tell us a little bit more about that, and what does that signify, and the different levels? You get my point. Sure. So tell us a little bit about the data side of things.
So I think Marco kind of introduced it there, that there's a device and the device reads different kinds of has sensors for different kinds of gases. So at the moment that's carbon monoxide and nitrogen dioxide. but it's extensible. So you could, join the project and help us add things like benzene and acrolein and other kinds of toxic gases that we need to monitor. The hardware and firmware guys were just talking a few minutes ago about the calculations that are done on the board to try to turn, the data that comes off those sensors into basically a parts per million reading for each one of those gases. That then gets transmitted up via software that you guys all wrote onto the cloud via the IoT platform, where we collect together all the information from all the sensors and all the firefighters in the field. And that's captured minute by minute. And then that's when we kind of take over with some data analytics and running some processing in the background. So I think when we started off on this, I kind of naively came in thinking, hey, it's all about parts per million levels. So, if you go above a certain level, then you're in danger as a firefighter, and below that, you're okay. But it really isn't about that. It's more about your exposure over time. And there are different time windows, over which you can be exposed to certain amounts of gas, which is safe, and then longer time windows when even that small amount is not safe. So what Prometeo does is it calculates those exposure values over multiple different time periods. And as Dan was saying earlier, all of that is configurable. And one of the reasons for that is when we went out and started reading about how it works in lots of different countries and how those occupational health standards work in different countries, we found, they're similar, but they're different in pretty much every country. So the Prometeo solution as it stands today is configurable for different, I guess, regulatory regimes in different countries. And can be extended to kind of suit whatever works in a particular country. So yeah, I think that kind of gives an outline of it. Marco, anything to add to that?
You explained very well. The point is that we have the real-time data analysis, no? When we analyze trends in real time, so we are seeing the firefighters, and we can give this information to the command center in order to decide what to do with a firefighter that he's in red, for example, or he's in a yellow zone. And we store the data. So for the future, we can see if there is some correlations between the exposure to toxic gases and some problems that can have with the health the different firefighters, no? So for later studies, I think this is important information that we are getting from the firefighters.
Yeah, and it was amazing to see John and Marco, you guys working together. But for Marco, I think he's touched basically every single piece, like writing in C and then Python and then JavaScript. So I'm very, very impressed.
Marco's the Batman of the team. He can do everything.
Thank you. I did my best, but anyway, it was an honor to work with you because you are very expert in the different fields, and I learned a lot from you.
This team's amazing to work with, for sure. So we have two questions from the audience. The first question from Alexander is, I think maybe you answered it just now, is what protocol is used to connect the edge device to the cloud? Is it MQTT or other protocol? And I think, John, you said it was MQTT that was used.
Yeah, Upcar, you're the best man to answer that question.
So I was trying to hide myself as the host. But,
I'm sorry, you added yourself right at the start. So.
All right, yeah. So Alexander, that is correct. We use the IBM IoT platform, which there's a client working on the phone, as well as there's a client on the back end that's talking to the IoT platform using MQTT protocol. But the next question, maybe for you, John and Marco, what sensor is used? Is it CO or CO2 sensor? So maybe talk a little bit about the different gases that are being detected.
Yeah, Marco, do you want to take that?
Yes, we use a sensor that detects CO and nitrogen dioxide. So we detect a carbon monoxide. This is because at the beginning we were using the CO2 sensor, but the firefighters were more interesting in the CO because it has a lot of effects in the body. So here we are speaking about the wildfires. So you are in an open area, so this is not going to kill you. If you are in a room, this is very dangerous and it can kill you, no? And you're not going to realize because it's a poison. And But anyway, in an open space, it can give you problems with your hair. You can feel have the headaches. You can have a dismay. So you have to have some information about what's happening to your body and what position you have in order to see the firefighters that it is reaching a dangerous exposition.
Yeah, I think that's really important. There's kind of two views on that, really, isn't there? There's like what's happening today in this particular fire event and how safe are the firefighters today, and then there's also the long-term monitoring that Salome was talking earlier on about. You know, what outcomes do firefighters see, and how does that correlate with what we tracked in the data that was being captured from their devices? One thing I would say actually about the gases is that and this is absolutely kudos to everybody on the team. The way the system is architected, if you're a developer or if you're a guy who's interested in hardware and you'd like to get involved in adding a new sensor, you don't need to know anything about how the back end works or in any of that software stuff. You can come in and add sensors that capture new data in the firmware, and that information will just get taken care of on the back end. And likewise, if you have new kinds of analytics or you're interested in applying some kind of extra data or machine learning, you can do that on the back end without necessarily having to know anything about how the front end sensors work. So the architecture is quite nice in that respect, in that it enables you to contribute in the way that you can contribute without having to know everything.
Yeah, that's very well put. Sorry, Daniel, you were going to say something.
I was going to add that, yeah, the CO is fascinating because, right, when the project was originally created, it was a real-time measurement, but it's really that long-term over time that's important, and especially since it's not, it's odorless, it's colorless, it's not something that a firefighter is aware of in the moment. And I think, the exposure over time is important, especially that it does dissipate in the blood very quickly relatively to other things. So if you're able to capture that soon enough, you can find the cause of it. And that's one of the key insights I think we got from the community. We talked to a large organization in the United States focused on carbon monoxide poisoning, learning how difficult it is to track and how difficult it is to diagnose hours after the fact. But if you have that insight real time combined with the shorter averages, that's really powerful insight. And particularly with the service corps team having bring the application from just that real-time information one way to the control center, being able to send that back to the firefighter, back to the field, and provide some actionable information is super powerful in the latest version of what was created.
Yeah, and again, for people who are watching this right now, I've put in the Slack information on the screen, so you can join our Slack Call for Code Slack workspace, as well as the Prometeo Slack channel, where you can come and talk to all of us there. So, all right, I think we're sort of running out of time, but my last question for the whole team here is, what's next? What's next for Prometeo? And maybe we start off with the hardware, then data, and then end with Daniel and Salome talking about the bigger picture.
Well, the future is version 4. We are starting new version. This is a journey without a stop. So the future is version 4. So we expect to improve the analytics. We expect to improve the IoT device and the platform itself. And to be honest, I would like to travel. So if the situation allows, we would like to do a field testing in version 4, at least in Argentina with Marisol, in US, in Australia, and in Spain. We would like to test the new version device at least in 4 countries, because the problem is global. So our community is global, so we would like to have a better solution to help firefighters. But the future of Prometeo will be made by them.
One point I think is that about the future of the device, now we are sending the data from the device to the mobile application using Bluetooth Low Energy, but you know that in some places you don't have coverage for the mobile, so maybe it has sent to use LoRa. So we'd like to include another solutions, maybe GPS in some places. For example, here in Catalonia, Spain, firefighters they have a GPS in their equipment, but another places they don't have it. So maybe it has sense to include the GPS use the smartwatch that we have for the solution in order to get more data from the smartwatch. For example, the stress of the firefighter, and we can include about the data scientist. It should be very nice if we can personalize more the data depending of different characteristics of the firefighter. So I think we have a lot of things to include, to do, and we have a lot of ideas, and maybe with your help we can develop these ideas or include new great ideas.
That's perfect. Thank you, Marco. So Salome, I was going to say we are all coming to you when travel opens up. So I don't know if you'll get to travel, but yes, we're all looking forward. I don't think the team, I guess the initial team met in person, but I don't think this group has met in person. Is that right?
Correct.
Yeah,
I
so
think
we're all looking forward to that.
Yeah. I think I was the only one that maybe met Salome and Marco in person with some of the early field tests. But the rest of the folks I've never met in person. I'm really looking forward to that. We'll get to Barcelona one day.
I would like to meet you in person. It will be great.
Post-pandemic churros con chocolate.
Count on
right.
the churros con chocolate y paella, and the typical Spanish.
And salmorejo, because I'm from Córdoba, so salmorejo is another food that we eat there.
Nice.
Wonderful. Thank you. So again, I would like to thank the team for joining me today at this office hour. Got to learn a lot more about the project. No, not me, the audience. We had a couple of questions, which is great. A lot of people are saying hi. There's a lot of hi's and hellos on YouTube. So hello back to everybody. And I've put again, the Slack link is at the bottom of the screen. So please come say hello to us in Slack as well. With that, thank you again, team. Thank you, and nice to see everybody again.
Yeah, good to see you all.
Maybe.
Thank
you
you.
very much.
Bye.
Bye.
Bye. All right, so that was, let me take this banner off. So that was Team Prometeo, who you heard from. I'm part of that team as well. Again, come join us on Slack. It's at the bottom. Oops, this side. It's at the bottom of the screen. You can come say hello to all the team members and ask your questions there as well. And don't go anywhere. We'll have JJ come on and present to you in a couple of moments. And again, thank you everybody for attending Think and the office hours and hanging out with us today.
There we go. Sometimes you got to hit the right button. Hello, everybody. My name is JJ Asgar, and I am the host for today's office hours, or office hour, 30 minutes. And I have three friends of mine coming in, and I'll bring them in here. Here we go. And I don't have video yet for Core, so if Core, can you go ahead and fix that for us real quick? Yes, I'm going to go around the room real quick and introduce yourself. Paul, do you mind starting?
Hello.
Can you tell us who you are?
We can hear you.
And and kind of introduce yourself to the audience, please.
Yes, sure. I can go first.
Sure.
Hey everyone, my name is Shivam Solanki, and I am a senior data scientist, also working in the role of data and AI architect at IBM. So my team is hybrid cloud build team. We work with ISV and GSI partners, helping them onboard to the IBM technology, mostly IBM Cloud and Cloud Packs, Cloud Pack for data specifically for my role. And here we had a partnership with Robin where we onboarded Robin to Cloud Pack for data in the partners catalog as our cloud native storage. So yeah, that's all. Thank you.
Cool.
Hi. Hey, hi. My name is Ripul Patel. I'm a senior architect here at Robin.io. And my primary role here is to basically create the storage stack here that we have developed in-house. And we started engaging with IBM to integrate for Cloud Pack for Data, as the Cloud Pack for Data has various services that gets deployed on OpenShift, and all those services require storage services underneath, right? And with that, with various different kind of services, it requires it has so many different requirements. Like some has a higher storage performance requirement, some has backup and restore, some has snapshots capability required. So so we took all those requirements in and then integrated with Cloud Pack for data to satisfy all these various requirements from different applications. That's it.
Nice, awesome. So this opportunity is so if you're looking in the chat right now on all the different streams we have, I'm looking at some of them. So if you have any questions, please don't hesitate to post them in there. This is an opportunity for us to kind of get to talk about the things you didn't get to talk about during your presentation here at Think. So Savam, let's go ahead and start with you first. What is something that you wish you could have said during the presentation, but due to time constraints or whatever you might have, you weren't able to go over?
Okay, so yeah, we had a couple more demos with Robin as a cloud native storage on IBM Cloud as well that we couldn't go through, and like because of the time constraint. But we definitely want to go through, and Ripul has already created those contents or those videos, and some of the IBM folks, the developer folks, they are also working on this to create these assets on developer.ibm.com, where all the developers like us, we can go on the website and we can try out directly, like going through the tutorial and getting our hands dirty with robin.io.
I lost my mute button. Awesome. That sounds great. So just to make sure that we're all paying attention here, on Twitch, we have a handful of people watching us, which is great. And then on YouTube, I know that we're streaming pretty well. So if y'all have any questions, again, please don't hesitate to post those things. Ripul, back to you. So again, we talked about some possible things we didn't get, some examples we didn't get to go with Robin.io. Were there things that you would have liked to kind of dig deeper into during your presentation?
Yeah, sure. So I think I will extend the answer that already you mentioned, right? That yes, we do have a lot of other capabilities that we could not show during the demo. We showed the capability with DB2, which is basically a database from IBM, and we deployed that on Cloud Pack for Data using Robin storage, and we showed the powerful features of basically taking the backup and restore, take a snapshot and restore of the DB2. Now here, storage services do provide all those features, but here what we really want to emphasize that all those with workflow are driven from the application point of view, right? The end user does not have to basically take backup or snapshot of an individual volumes that is being used on DB2, and they don't have to basically muck around or keep editing different YAML files to restore the application. The power of Robin basically comes into the way we basically take the application level snapshots and restore. That capability basically is what end user wants, right? So that end user can focus on developing their applications and not to worry about underlying infrastructure.
Nice.
Yeah.
So,
Adding to Ripul's answer, the level of abstraction provided by Robin is really great, because like as a data scientist or as a developer, I do not have much experience, or like most of my colleagues don't have experience with cloud native storage or storage. But like that level of abstraction that Robin provides, we don't need to have those experience or knowledge. We can just like use a couple of commands and we are good to go, working at the application level, taking snapshots, rolling back, going back to our timestamp.
So you're talking about the abstraction and how easy it was to put inside your workflow and your development process. What is something you wish you had known when you first started working with Robin as this partnership grew? Like what is something that was like, oh, I wish I had known when I first started using Robin.io?
First of all, for us, for our journey, it was the first step was installing Cloud Pack for Data on a cluster with Robin as a cloud native storage, as the storage in the background. So their cluster was on AWS, and I was very less experienced with AWS. So in that, like our first step, we kind of stopped a couple of times to get help from other teams, but Cloud Pack for Data support team and some of the BU teams in IBM, they reached out to help us, and then like we learned a lot, both of us, Ripul, myself, their team and our team, and like as our journey evolved, both of us kept learning and evolving.
Awesome. So same question to you, Ripul. What was something you wish you knew about the IBM cloud when you first started going down this journey? What surprised you about it? Oh, we lost your sound. Yep.
Yeah. So right. So when I started with IBM Cloud, right, and especially Cloud Pack for Data, I was really impressed with the way of sophistication that has done for the end user to deploy all these AI ML applications, right? For an example, if user wants to have a Watson Studio or Watson Machine Learning, the whole pipeline is designed, right? And the user has to come and just say that, okay, I want one pipeline of my application, AI ML application, and then user is totally hands off of basically piping in a different application with each other, stitching in each other, like application with each other. And not only that, right, even the storage layer has been taken care of by basically providing all these different storage offering on Cloud Pack for Data. So that was a really good experience that that end user has, right from installing Cloud Pack for Data to basically doing the first AI ML run using Cloud Pack for Data.
Awesome. So if I understood you correctly, you were pleasantly surprised that everything was already kind of built and you can just focus on putting where Robin.io value prop was into the pipeline. So all of a sudden it just magically came together.
Right.
Is that what I'm hearing? That's awesome. That's great. That's great to hear. So going down this path, obviously y'all came up with some really good architecture and use cases that you were talking about a moment ago. So was it the what's I'm looking for? The reference architecture that you built to kind of tell this story with Cloud Pack for Data and how easy it was? What was the biggest challenge? What was the thing that, like, we talked about positives, let's talk about negatives, because every project you do, there's always something that comes that you don't see coming that hits you. and you're like, what is this? What was that for y'all? Either of you can answer that.
Yeah, so I can go. So one thing that actually for me that we could improve on, right? So this is a very complex platform, right? We have here the bare metal servers or any cloud VMs, right? On top of that, OpenShift is layered on, and on top of that, all these services are layered on, and those services are basically using storage services underneath, right? So one thing that we had struggled in is while we integrate, right? We do have to make sure that Debian's, as I mentioned, right? Some services have very specific requirement, and sometimes since it is on Linux, as a Linux, we need to make sure that even security and everything is taken care of, right? So, in some moments, I really needed help with IBM folks who are really hands-on on Cloudflare for Data to basically help me with go to the next step. And that's why basically Shivam and his team basically helped me out to find the right folks in the IBM ecosystem and to basically go forward.
I would like to add something to Ripul's answer. So some of the difficult parts here integrating Robin.io with Cloudpack for Data are one thing is that like there are so many moving parts when you are working with Cloudpack for Data. For example, even if you are considering 3 services like Watson Studio, Watson Knowledge Catalog, and say Watson Machine Learning or DB2. With these 3 services, you have a control plane that is basically the base of all these services, the base service. And then you have OpenShift that can sit on any cloud, be it AWS or IBM Cloud or Azure. So there are so many moving parts. There are so many dependencies. And like with these many moving parts, it is always like difficult to get at the right documentation and like follow one certain path, because you have so many branches, you have so many trees. So like following one was very difficult for us, and like once we got the right documentation, then like it kind of started getting easier for us. So that was an initial challenge for both of us.
Nice. Yeah. It's funny. I had an open or an office hours or office 30 minutes. Just like that with this exact same statement. Another project was like, it was great until we had to find the documentation, and then finding the documentation was the biggest problem we had. But as soon as we got it, everything just came together, which is great to hear. But it just is one of those stories. Go ahead.
Yeah.
Ripple.
Yeah. So like installing Cloudpack for Data on ROX cluster, that is the easiest like you can do, because like we have everything well defined on IBM Cloud. You have the Red Hat OpenShift Kubernetes service, and like the documentation is superb. But then you go like OpenShift on Azure, then the documentation is not that superb. It's like say 80% or 90% of what you get on ROX cluster. So that's how like different branches is split, and different variability. With the variability, the documentation also changes a bit.
Right. And the minimum requirements, right, to meet those also, it is a challenge on every different environment. Like as you mentioned, that ROX cluster takes care of all those things. But then if you are trying to do this on AWS or GCE, then basically it's a different challenge.
Nice. So we're about halfway through our 30 minutes here. I did want to give y'all an opportunity to say anything to this audience that's watching us live or in the future, because there will be replays of this. So what would you like to tell people out there about that we haven't discussed, Ripple?
Yeah. So I think one thing I would like to emphasize in this, right, that other than features, other than usability, we also need to make sure that performance of the storage stack is adequate, right? In here, when a Cloudpack for Data is not an application, it is actually a platform on which basically there are many various applications will be deployed, right? There will be not one instance of DB2. There will be like tens or maybe hundreds of DB2 instances in the production environment. So as things grow in the cluster, there will be contentions on the storage layer, right? And a storage layer needs to make sure that all applications, none of the applications are starving for the throughput or for a latencies and anything of that kind, right? So when basically somebody is picking which storage layer is good for me, they need to consider the performance, but not only like the isolated environment. They need to consider performance when hundreds of apps are running together. So that is what something I would like to emphasize.
No, it's good.
And
That's very good.
And the performance is especially important when you are dealing with machine learning applications, because you don't want your model to wait for like 5 minutes to get in the get the data, pull in the data, and then apply your algorithm and return your prediction or classification or like whichever task you have performed, a clustering algorithm, say. So it's very important. And besides the performance, I also want to reiterate the application mobility capability of Robin.io. So I have worked with a lot of IBM partners who migrated their cloud pack for data from one cloud to another. Mostly it's either AWS to IBM cloud or IBM cloud to AWS. So in that case, if you have Robin installed with cloud pack for data, it is very easy to migrate your entire cloud pack for data or the applications inside cloud pack for data from one cloud to another without losing any single data. That's one of the key capability of Robin.io.
Nice.
So to further expand on mobility, right? Since Cloud Pack for Data installs on OpenShift cluster, and OpenShift clusters can be registered on satellite location now. With IBM Cloud basically has a new product called IBM Satellite, and it can manage your different your resources in various different clouds, or be it on-prem. So you can register those OpenShift cluster with satellite, and from single pane of glass, you can basically move your workload across different clouds using if it's using Robin storage, using the Robin mobility.
Nice.
And that is one of the reason I was talking earlier, like you should go and check out on developer.ibm.com in a couple of days. All these tutorials and code patterns will be available, where we show the key capabilities of Robin.io on IBM Satellite, Cloud Pack for Data, and all types of Kubernetes application or OpenShift applications.
Nice. Well, we're about 5 minutes away from our ending time, and from what it sounds like, we need to end on time. Is there any last thoughts that you'd like to give to this audience?
One thing, feel free to reach out to Ripple and myself if you need to know more about Robin.io, or if you have any doubts related to Robin.io. Maybe I should drop in my email.
Actually, what's pretty good, because we're gonna have rewatches of, if you change your name, if you click on the little 3 dots and change that to your email address, it'll show up on the screen. Okay. So then we can just have people, if it's okay, email you directly.
Yeah. I'm just
Ripple, if you can do that too, that would be wonderful.
Yeah.
And you'd be genuinely amazed on who will reach out to you when people do watch this, because people really do need help working with these things, and they'd love to get that. They love to know there's a face to that name.
Yeah. See, somehow I am not able to write anything in the chat window. Would you be would you be able to
not in the chat
for me?
So JJ was saying, if you click on the 3 dots on your icon in the bottom, you will get an option to edit your name, and you can edit it to your email ID so that everyone can see for the time being.
Perfect.
Yeah, and one more thing, right? That if anybody is interested in trying it out, they can always go to get.robin.io, and a free community version is already available, which is valid for 5 nodes and 5 terabytes. So anybody can just play around with it and then put it in their environment.
And that again makes our tutorial even more useful for all the developers out there wanting to try their hands on.
Awesome. Oh, we got a visitor. You want to say hi? Hello. Hi. It happens to the best of us. It's all good. Wonderful. Wonderful. Well, I guess then that's no better place to end it. Thank you, Rapul, for being here. Thank you, Sharon, for being here too. I mean, things coming close to an end, but I look forward to reading the code patterns on IBM Developer when they get released. Thanks, y'all.
Thank you. Thank you, everyone. Thanks, JJ. Thanks,
Thank you.
Vipul. Bye.
Bye.
All right, and that is the office 30 minutes for Cloud Pak for Data. And the title, I'm going to go ahead and drop off myself, and our next host should be along soon. Thanks, y'all.